proof by mathematical induction example. In this example, we want to prove 1 squared plus 2 squared plus 3 squared plus up to n squared, where n is a positive integer, is equal to n cubed divided by 3 plus n squared divided by 2 plus n divided by 6 using mathematical induction. So the idea behind mathematical induction is similar to domino effect. If you prove that that is correct for the first possible choice for the unknown, which is in this case n equal to 1, and then if you make the assumption that this whole thing is going to be true for n equal to k, well, k is a positive integer, then based on that, which is referred to as induction hypothesis, if you can prove that then for n equal to k plus 1 is also, this whole thing is going to be true, then by mathematical induction this is proven. So the first step is we prove what is referred to as basis step, in which we're going to make the assumption that n is the smallest possible value that it can be given the domain. So in this case we would say in basis step n equal to 1, and for n equal to 1 we have only one component on the left hand side, which is 1 squared, and for the right hand side we have 1 cubed divided by 3 plus 1 squared divided by 2 plus 1 over 6. Obviously the sum of these guys is 1, so both sides of equation same thing, therefore the basis step is proven. For the inductive step, which is the part that is similar to domino, what I do is we first assume that this predicate statement is true for, we first assume for n equal to k, where k belongs to domain of positive integers, k is a positive integer, this is true. So what we can write is 1 squared plus 2 squared plus 3 squared plus up to k squared, n equal to k, is equal to k cubed divided by 3 plus k squared divided by 2 plus k divided by 6. Let's name this equation 1 or equation A. It has its left hand side and right hand side. I'm going to refer to those. Now the idea is this is referred to as this is induction hypothesis. So with this we need to prove that for n equal to k plus 1, where k is a positive integer, this is also true. So 1 squared plus 2 squared plus 3 squared plus obviously k squared plus n equal to k plus 1 squared is equal to k plus 1 cubed divided by 3 plus k plus 1 squared divided by 2 plus k plus 1 divided by 6. That's what we want to prove. Alright, let's start from the left hand side, because you can see that on the left hand side this portion is exactly the left hand side of equation A. So substituting this portion from what we have from induction hypothesis in equation A, I can just replace or substitute this with the right hand side, obviously. So using induction hypothesis, basically the left hand side of A actually using the right hand side of A, we have k cubed over 3 plus k squared over 2 plus k over 6 plus k plus 1 squared is equal to, alright, let's check if the right hand side of this whole thing is equal to the left hand side. So what we have, expanding this binomial expansion, we have k cubed plus 3k squared plus 3k plus 1 divided by 3 plus k squared plus 2k plus 1 divided by 2 plus k plus 1 over 6. Okay, so what's going to happen is let's keep the k cube over 3 from the first component, this component. Okay, let's keep the k squared over 2 and let's keep the k over 6. Okay, so that is very similar to this portion that we have on the right hand side, plus 3k squared over 3 of course k squared, plus 3k over 3 is k, plus 1 over 3, plus 2k over 2 is k, plus 1 over 2, and here only 1 over 6 remaining. And we are done, because this thing is k squared, k plus k is 2k, and 1 over 3 plus 1 over 2 plus 1 over 6 is 1. And this thing is obviously k plus 1 squared, which is exactly the last remaining component on the left hand side. So right hand side is equal to left hand side. We prove it. So basically proved. So by mathematical induction, we have 1 squared plus 2 squared plus 3 squared plus n squared equal to n cubed over 3 plus n squared over 2 plus n over 6 for any positive integer n. Hope this helps, and hope you find this a good example to walk through steps needed to do the mathematical induction.